Hello everyone, welcome to my channel. My name's Aidan. Today we're going to be looking at a generator which has got no electrical output, although the engine's running. So I bought this generator a few days ago with the intention of fixing it. So I thought I'd make a video showing how I'm going to diagnose and repair whatever it is that's causing the problem. So here's the generator. It's a Clarke Power 700 watt generator, model G900. It looks like it's a fairly old unit, but hopefully it's got some life left in it. I'm going to fire it up just to see how well the engine runs. So just before I start it up, I'm actually going to check the oil. So I think that's, well, just above the minimum, I suppose. But for now, let's just see if it starts. So choke lever's already in choke mode. We need to switch the engine switch from off to run. So do that, and then hopefully it will start. Okay, so it started fairly easily. Sounds like it might be misfiring slightly, but that might just be because it's been sat for a while and maybe the fuel's old. So that's probably something else that I'll need to do, is to put fresh fuel in it, maybe change the spark plug, clean the air filter, all of that usual sort of maintenance stuff. But for now, what I'm going to do is take the side panels off, which hopefully will give us a bit of a view on the inner workings. Put that to one side. Okay, so this is obviously the actual engine. We've got a crankcase here, and then this will be the generator. So it looks like we've got some kind of electronics module there. So I'm guessing that's a sort of rectifier or diode pack, and then some kind of resistor there. One thing I haven't done actually is I haven't actually plugged anything into it. So it might be worth just plugging something into it and seeing if it actually works, because, well, I'm only going by what I was told by the seller, so it's worth just doing a little test. Okay, so I've just doing some testing, because this is basically a DC 12 volt output designed for charging 12 volt batteries. And I thought, whilst it's running, let's just see if there's any voltage there, and it doesn't seem like there is, or, well, there's very little. So I suspect that as there is voltage, but just not very much, it's probably something wrong with the voltage regulator or the rectifier circuit. I did try plugging an LED work light in, because I thought that's a fairly low power load for it to test it on, but unfortunately that didn't illuminate. So I think we'll have to start taking this front cover off, and that should give access to the electrical components. So I'm going to take the other side panel off, and then I should be able to take this front panel off after doing that. One thing I've noticed as well is it's missing a foot, which is probably at least partially why it vibrates as much as it does, but in general it's actually fairly quiet. I think what I'll do for the missing foot here is actually just 3D print a replacement. It looks like it's the engine switch that's just holding it up, and I've just looking at it. It looks like it electrically switches the ignition on and off, and it also shuts off the fuel supply. And I think it's the connection to the fuel tap that I need to disconnect. So the fuel tap connection is just in here, and it's this screw here. So as we turn the engine switch, it's basically rotating that So I'm going to remove that screw or loosen it, and then hopefully the front panel will come free. It seems this front panel is somewhat structural as well, so the fuel tank and sort of lid, if you like, is supported partially by this. So we can see the end of the alternator, I think it is, and we've got a couple of electrical modules. I think this is some kind of resistor, I imagine. We've got something down here which is probably the diode pack, and then we've got another module, a larger module here. Not too sure what that is, but maybe it's some kind of rectifier or something. I think what I'm going to do is take off the pull starter and see if I can see any identification on those modules to work out what exactly they are. Okay, that's the pull starter. Let's put that to one side. So this module here is held on with a Phillips screw. So I'm gonna leave the connections connected and remove this screw and see if there's any markings on here at all, because then we can find out what it is and how we can test it. Okay, so we've got some markings there, which is hopefully a part number of some kind. Okay, so it seems that module with SB256 printed on the side is actually a bridge rectifier. Okay, so what I'm going to do is I'm going to take the other module off as well, just to see if I can identify that, and then I'm going to go away, do some research on both, so I know how to test them both. There is some identification on the other side of this module, so I'm just going to take a picture of that and work out what it is. Alright, so as far as I can tell online, it looks like this component might be a capacitor, and it does say 12 MF on there, which could be 12 microfarads, which would sort of make sense. But so I just need to find out where the wires go so that I can disconnect them. So it seems as though it's this bullet connector here, and I'm guessing it's the other one as well. So I'm going to just reconnect that, because what I don't want to do is lose sight, if you like, of which one's connected where. I'm not sure if it actually matters if this is just a non-electrolytic capacitor. It won't matter which way round the wires are connected, but I don't want to take any chances. There we go. Right, so both wires are the same colour, and the connection isn't great, so I don't know if it could just be that it's not got a good enough connection. But anyway, so we've got access to the capacitor. I think what I'll do is, as both wires are the same colour, it's probably fairly safe to assume that it's non-polarised or non-electrolytic. There's the front of the capacitor showing the specifications. So I interpret that as 12 microfarads at 250 volts AC, and we've got a manufacturer's name there of Shilung and a little logo. Okay, so I've got my multimeter set up on capacitance. First step, I'm just going to discharge the capacitor just to see, well, just to make sure that any residual charge is removed. And now I'm going to connect my test leads Okay, so the indicator light at the top, which is just out of shot, so I'm repositioned. There we go. So the indicator light at the top. Let me just discharge this again. So the indicator light at the top is currently off, and apparently it will switch on and turn yellow whilst the capacitor is charging. And then turn green once it's charged. Okay, so it's just turned green, and we've got OL on the screen, and according to the manual, that indicates that the capacitor is either short-circuited or its capacitance is outside of the range of the meter. So what I'll do next is measure the resistance across these two terminals, and I guess it should be a relatively high resistance if the capacitor's okay, and if it's a low resistance or comes out as a sort of short circuit, then I guess this is dead. So I'll have to try and find a replacement. So let's go on to continuity and see what happens. So this should have quite a high resistance. Okay, we've got 0.4 ohms, so I think it's quite clear that this is the culprit. So I'm going to try and source a replacement capacitor. I'm not quite sure where I can get one from, whether I can get one locally or may have to order one online. But yeah, so it should be a fairly easy fix. Just change that and then hopefully the generator will work again. Okay, so I've just been out to an electric motor repair company and managed to buy this, which is it's actually a motor start capacitor, but it is of the same capacitance value as the one from the generator. Slightly higher voltage, so this one's rated to 450 volt AC, but it doesn't matter. I think a higher voltage is actually better, so it should be a slightly more durable part. The only issue is it looks completely different to the one I've just taken off, so we'll have to work out how I'm going to actually fit it. So before I worry about mounting it, I'm going to basically connect this up temporarily just to test it and make sure that it is actually A, compatible, and B, that we've solved the problem by replacing it. So I'm going to just mount the rectifier, as I don't think that's the problem. I haven't tested it, but the findings from testing the capacitor suggest that it is indeed the capacitor that's the problem. And researching online seems to suggest that it's not uncommon for these capacitors to fail. So we've got bullet connectors on these. This is a female bullet, so I'm going to just have to make up some leads to connect this to that. So now I can use my adapter cables that I've just made to go from the bullet connector, which I believe comes from one of the coils in the alternator, and then connect the capacitor at the other end. Now you'll notice that these four terminals are in two groups, so these two are linked together and these two are linked together. So we basically just want to make sure that our connections are on, one's on one group and one's on the other, otherwise you've got a short circuit. Not sure if that will cause any damage. I suppose it potentially will, so definitely want to just make sure that that's correct. Now I'm just going to try and put these wires out the side, and I can mount the pull starter. One thing we need to be aware of here is that we need to make sure that shaft goes back into place into the fuel shut-off valve, which is just there. Okay, so the generator's back together minus its side panels. So at this point I think it's ready to test it before we go any further. So I'll just use this to test the generator. So plug it in, switch it on to run. Let's put the choke on. It's not very cold, but put it on anyway. So as we can see, the generator is now working. So I might just try it with a slightly more significant load. So I'll find something a bit more powerful. Leaf blower, 700 watts. So I guess in theory it should power this, although it might struggle a little bit. Yeah, so it seems to power the leaf blower okay. So now the generator's working, just need to work out where I'm going to mount this capacitor. Of course, it's quite a compact little generator, so there's not really much space inside for this to go. Because I don't want it rattling around, I want to try and actually secure it to something. So I'm just going to work out how exactly to do that. Alright, so I just found this random little strip of metal with 2 holes in it, so I'm hoping that I can just put this screw through one of these holes, and then with some careful bending, hopefully I can get it into the right shape so that it's basically, I'll twist it and then kind of bend this bottom part up slightly. Okay, so I'm going to mount this in the vise, and I'm going to grab a decent pair of pliers. And basically I'm going to create a sort of 90-degree twist. Like that. So I'm sure I'll need to create some more bends in there as well. But that's a decent start point. Yeah, I think I might need to add a bend to this part, or that part, whichever, doesn't really matter. But just to sort of angle it like that. So I'll do that next. Not sure the best way of doing this, but I think I'm just gonna, I'm just gonna do it with the pliers. Okay, so that's our bracket, hopefully. So I think with that position there, that should put the capacitor in roughly the right place. So yeah, I'll drill a larger hole in this. Right, so there's our 2 holes. So we've got the larger one for the capacitor, and then the smaller one for mounting it onto the generator. So it looks like I might have to mount the bracket behind the pull starter assembly, otherwise it can't quite go at the angle it needs to. Alright, so I think that should do the trick. So the capacitor is now pretty solid, and we've got enough space at the bottom for the electrical connections. I might need to take it off again just to attach the connectors, but I just wanted to make sure that I got it mounted securely anyway. So yeah, quite happy with that. Alright, so I've just remounted the pull starter. What I've done is I've just put a washer behind each of the 2 mounting points just to kind of try and match the thickness of this bracket that I've made. The washers are slightly thinner, but it should just help to level that out slightly. Alright, so we're ready to put the front cover back on. Remembering to connect the little shaft that goes to the fuel cut-off valve. So I'm just going to make sure that the stop switch is in stop, and then locate the shaft just in here as I showed earlier. Alright, so it turns out that the capacitor doesn't fit in the original location, so I'm going to try flipping it upside down. Alright, so I've just loosely repositioned everything with the capacitor flipped upside down. So the wires only reach to there, so they definitely will need to be lengthened. But first I'm just going to see if this side panel will now fit. Almost. So we're left with a bit of a gap. Less so than before, but it's still not quite right. It's got a much more severe angle to it now, so if that doesn't fit, I think I might have to get a new piece of metal and try and work something else out. Okay, that seems to be alright now. I think it's probably still resting on it slightly, but I'm not too worried about that. Capacitor's going to sit there. I think I'm going to do it on here, because that's going to miss more enough. Yeah, I'm going to do it there, so I'm going to do that. Yeah, that's nice and secure. And now we can get the side panel on, and hopefully this time it should fit without any issues. So the generator's now all back together. It seems to have gone together all right. So I think relocating the capacitor was obviously what was needed to get that cover to fit properly. What I'm going to do is give it another test, take it outside so I can run it for a little bit longer. All right, so we're outside now. So put the choke on, turn the switch to run, and then hopefully it should start. So I'm still using the leaf blower as a load. And what I'm going to do is just measure the output voltage. Okay, so with no load it's actually quite high, around 260 volts. Let's see what happens under load. So with the multimeter set on frequency, it looks like we're getting just over 52 Hertz. It's fairly stable. So it fluctuates quite a bit under load. Okay, so the last job is to replace that missing foot. Right, so I've got my vernier or digital caliper. Just going to take some measurements of the foot so that I can 3D print a new one. So now I'm just using those measurements I took to 3D model the foot in Fusion 360, which is a 3D CAD software which is free to use. So if you want to learn more about that, then perhaps leave a comment and maybe I'll do a video on that in the future. So now I'm just taking that 3D model I've just created and importing it into the 3D printer slicer software, which basically transforms the 3D model into a file that the 3D printer can understand. So a nice feature of the printer that I have is that it has a built-in camera, so we get a nice time lapse of the part being printed. Okay, so the print's finished, so we'll take a look. Quite happy with that. It took 33 minutes to print. Okay, so there's the new 3D printed foot in place. comparison to the old rubber foot, I think, yeah, I think it looks quite good. Okay, so that concludes the video of the generator repair. So if you have a small portable generator and the engine runs but there's no power output, it's likely that it's the capacitor. So as you've seen, it's quite easy to test if you have a multimeter. So I was able to use a motor starting capacitor, which cost me £10 from a local motor repair shop. So it was a very cheap and relatively easy fix. I guess the hardest part was just working out where to mount the new capacitor, since it was a slightly different size and shape to the original. If you were just doing a like-for-like replacement, then I can't see it taking more than half an hour in total. Yeah, so that concludes the video. Thank you for watching. If you did enjoy it, please give it a like and subscribe. I'll be doing some more videos in the future on various repairs, so stay tuned and I'll see you in the next one.